Hello and welcome to Adafruit's Show and Tell. It's me, Noe, and Pedro. We're hosting this week.
Hey guys.
Yeah.
Welcome to the Adafruit Show and Tell. This is the best place to show off your awesome projects. It could be any electronics, 3D printing, or just a tour of your studio. Everything is game. Go on and join us at discord.gg/Adafruit to get a link to show off your awesome projects. I'm going to start off with a lot of people in the Adafruit community. And we'll join over on to anybody on the Discord who joins. Let's go ahead and start off with very awesome Scott.
Hey, thank you too for hosting, and thank you for having me. As folks know, I've been working on Matter, which is this supposed to be end-all be-all IoT spec for integrating your temperature sensors and stuff with your Apple HomeKit, your HomePod Mini, or your Google Home. All those big companies are working on this new spec that's supposed to be the end-all be-all, basically interoperable and secure and all these things. So I'm working on that. I'm implementing it in Python, and I hit a milestone today, which is what I'm showing this output here. But the most exciting bit is this last line that says successfully validated attestation information. Basically, they are worried that they're preventing devices that are not certified from getting on the network without telling you. So like attestation is about making sure that the device is what it says it is, and it was created by who it says it was, which is a lot of cryptography, key signing stuff that I don't really understand. And they have a path for test devices and hobby devices. So that's the way we're going around here. So we actually have this like certificate that declares we're not actually officially certified. Is what we provide to it. And so that's what we've gotten going so far. And now I'm just moving on to the next step, which is more certificate work for getting onto the network securely in the future. So one baby step at a time through the complexity of the Matter spec. But my goal is to make an RGB light that you can control from your Apple Home or Google Home, whatever it is. Integrating with all those other devices. So one step at a time. Deep dive Friday on 2 p.m. And the last couple have also been on Matter. So if folks are interested in that, there's hours and hours of me working on Matter if you want to watch it.
Super cool. And we just added a new word to our vocabulary. Awesome.
Yeah, attestation. It was even new to me.
I was gonna
word of the day.
Find a way to use that in everyday talk.
Cool. Yeah, we're talking in the meeting just how many layers you have to like kind of weed through. So it's nice seeing. It's slow but very steady.
Yeah, it's slow but very steady. It's very clear that it's a bunch of big companies, right? And the way that they design the spec is like, you do this level, I'll do this level, I'll do this level, and then at some point they get back together and they'd be like, oh, like we actually duplicated it here, or like we said there's all these different data types, but underneath we just transfer it in these data types and blah blah blah. And it's just like designed by committee is kind of how I call it.
Exciting.
Sounds like
yeah. But
cool.
I have some devices here that are like actual certified devices, and they do work quite well. So I think generally a lot of the complexity has been worth it.
Awesome.
So yeah, I'm looking for this happy path where we can get a light bulb going before I disappear to be a dad again.
Very cool. All right, Scott. Have a good evening.
You too.
Thanks.
Bye. All right, next up, you want to check in with Jeff?
Jeff. Yo.
Hi there. So I've got two different things I'm going to show tonight. One's a little bit more prepared and the other's a little more off the cuff, but we'll start with this. So I think a lot of people have heard about this thing in the Pico 2 or the RP2350 called the E9 errata. And a lot of people have investigated this, and I kind of did my own part. Dan, who works on CircuitPython, looked into this deeply and said, although there's a workaround suggested by Raspberry Pi, that isn't going to work for us to make touch inputs work. And I was just curious why that is. And so I've got some graphs that I captured from my oscilloscope, and I was going to say a little bit about them to try and show what I learned, and maybe you'll learn something too. So in this first set of pictures, this is what it looks like on an RP2040. This is on an Adafruit Feather. This is the voltage that the microcontroller is measuring as it's polling the touchpad. And so it sets the voltage up to a high value and then lets it slowly decay. And it measures this time that it takes to decay. And that's the raw touch value. And it does that 10 times or so. And then it reports, I think it's the average or the sum of all those. And then when that's done, the rest of the charge drains out of that touchpad until the next time that you're going through that cycle. So that's what you're looking at here. This is when it works on an RP2040 and how it works on other microcontrollers. And then I've got just a couple of zoom ins on what that looks like. And so like at the it's just very slowly sloping down in a way that's called exponential decay. And that's what the code is interested in measuring. So Raspberry Pi's workaround for the E9 erratum, the E9 erratum will like make the voltage of a pin rise up to 2 volts if it's not being pushed one way or the other by something external. And Raspberry Pi says that the workaround is to turn off the thing called the input buffer. But that means while the input buffer is turned off, you can't check the value of that pin, whether it's a true pin or a false pin. And so this is what happens when you try and apply their workaround. Again, you get this dropping part of the waveform. And then about here is this voltage that it likes to force the IO pin towards. And so when it drops past that, and then the code says, I want to read it and check whether it's low or not, that makes the voltage very quickly rise up again. And so here, but it has to rise up every time you want to check. And in the old one, we were checking like 9,000 times within this time. So, you check quite a lot of times. Here you can see, because we see this uptick every time we check, we're waiting, I think it's 20 microseconds between them. So we only get to check like 6 times. So even though this kind of works, you would get a very poor granularity. And if it charged up just a little more each time, see how little it actually drops before it's pushed back up. If like the values were a little bit different, then maybe it would get pushed, all the way back up to that value every time, and it would measure like infinity of touch, because it would never go down. Oh, wow. And then this is really zoomed in, and this shows, it's basically a straight line, and then just for let's see, for 120 nanoseconds, it just shoots it back up that far. And so this was just really an investigation for me of why did Dan, who looked into it first, say this isn't going to work, because Raspberry Pi said this is the workaround. Why is it not the workaround? And I just wanted to understand that a little more. And this is kind of my investigation into it. So maybe a little bit technical for show and tell, but that was the first thing I wanted to show. Any questions? You want to talk about the second thing?
No, you explained it pretty well. And I always appreciate a visual representation.
Yeah, visually seeing the graph, you're like, oh, okay, this is why it's not working.
Yeah.
So, So the next thing is, we've been talking internally. There's a lot of great stuff about the RP 2350, and we're really excited about it overall, even though there's this kind of one thing that has dominated a lot of the talk. And I've done a lot of audio projects or audio coding. I think that other people do the cool audio projects. And so I want to preface this by saying this is not a great demo. This is just the demo I could put together in 5 minutes. But the question was raised, can we play more than one MP3 on the RP2350? Because it's got the more powerful Cortex M33 CPU. It runs, I think, at 150 megahertz by default. I should try this demo with it overclocked. And so the answer is, you can create memory for 11 MP3 decoders if there's nothing else in your program.
Nice.
So that's pretty cool. But how many MP3s can you play back in practice? And so here in this demo, I'm opening the same MP3 file from the internal flash 9 times, and then creating a mixer that kind of matches those characteristics with a nice generous buffer size, setting up my I2S out. And then for each of the decoders, I play it but I start at like a length of time apart. So it's going to start one, and then 2 seconds later, it's going to start another copy of the same file, and it's going to go to all 9 files. And this is an Adafruit Bartlebeats track, so I think it's okay if I play it on the stream, but also it will just sound like cacophony when it's playing all 9 of those. So here we go. We'll see what just my mic picks up, but this is a Pico 2 hooked up to an I2S DAC, and then into my desktop speakers. So let's try it.
Let's hear you, DJ.
It just gets more and more frantic.
Yes.
7, 8, 9 voices. So anyway, I was excited about that, and I think if somebody like has something good to do with 9 MP3s, this will be really cool. So I will post this up as a GitHub gist in just a minute. But that's what I had to share with you tonight. Kind of what was everybody talking about with RP2350, and here's something cool you can do with it that we haven't been able to do with another microcontroller before. So yeah, that's what I got for you tonight.
That's awesome. Yeah, I'm looking forward to playing with it. I got a couple kind of sample sound boxes that I'd like to remake with it. So excellent to see that.
Yeah, so like with this, you get to set the level of each MP3 individually. You can start and stop them individually. So there's a lot of stuff here that you can do. And yeah, creating sound boxes, or like I have this, I kind of want to do one of those ambient boxes where it's like got one kind of loop, and then it like picks an animal noise or another animal noise, and we could just do, you know, one bass loop and 8 animal noises, and wouldn't that be cool?
Could be a good kind of project for the kids.
Yeah.
Cool. Well, sharing that. It's exciting.
Thanks, and see you around.
Layers. Awesome. Thanks.
All right. Bye. All right. Let's check in with Anne. Hey.
Anne.
Hey guys.
Hey.
Adventures with Old Computers, part 16. I think I mentioned I've got an old IBM ThinkPad. Has a Pentium M processor. It's from approximately 2003. So it originally ran Windows XP, and I got it with no hard drive, no operating system, just kind of. So I dug it out today, and I found out with the power supply, I needed to use the dock I have. And it's really kind of a neat dock. Let me show you real quick. Look at all these ports. If I can get the angle right there. It just comes with every single port, but you can see that there was the lock mechanism. And for some reason, I didn't have the key. And it's like, it happens. So
you lockpicked it?
Well, your federal government taught me about 27 years ago. No, more than that. 30 some years how to use
you had to do it.
That's great.
As part of my job. So
nice.
You know, picking a house lock is really kind of tough, at least for me, because I'm not a practiced person. But I just put the tensioner in, I braked it once, and it went whoop.
Oh, funny.
So it is not a high security lock. Don't expect that to be. But I used the CD-ROM drive to try to install Windows XP. I was going to install it to an SD card that's in a hard drive holder to use as a hard drive, but it's from AliExpress, and I don't think it worked. So my kind of go-to with some of these things is to use like a low-profile thumb drive right here. And while DOS would load onto it, Windows XP didn't like loading onto a thumb drive. And it took me a long time to kind of get that done. So what I did is I had a CD-ROM of FreeDOS, and I loaded it on here. And FreeDOS with extras comes with free Doom.
Yes.
Everybody wants to see Doom on running hardware. So this is
perfect.
This is, you know, with
runs buttery
decent frame rate. Yeah. I forget what they're Yeah, there you go.
Yeah, this brings me back to like my early days of working at CompUSA. It's kind of
Oh wow.
Yeah. So seeing all that I/O and the lock, because we had a lot of things like that on display. Everything had to have a lock.
Funny.
Well, really quickly, I found like 8 of these in a dumpster with no hard drives or anything. And I took them. The idea is to maybe give them to kids or something. But what I did was I took that 8 and rehabbed them down to about 5 or 6 maybe that were working, had power supplies. I got either SSDs or thumb drives, and I donated them. This was when I was living in Germany. I donated them to be given for free to refugees who were coming in and wanted internet access.
Nice.
Oh,
So
cool.
yeah, so it put them back to work, and that was about 7 years ago. So this would have worked as a pretty simple internet appliance back then. The operating system I used was Raspberry Pi OS. They have a Windows, a Intel port of that, and it works really well. So, fun with old computers.
Yeah, for sure.
And thanks for having me.
Cool.
Yeah,
Thanks.
no problem. Yeah.
Have a good night. Stay safe out there. We know there's a bit of weather.
Yes, we have a hurricane kind of brushing the backside of us. It'll be rough.
Right. Stay safe.
Stay safe.
Bye. All right. Next up, let's tune in to some bright, beautiful lights with Erin. Hello.
Hello. How you guys doing?
Good.
So I am showing off today my light display. I'm actually going to be installing this at the local Arden Fair shopping mall in Sacramento this weekend, and it's going to be up for a couple months. I'll take you on a little tour. So the main attraction here is my crystal walls. So these are something I made during COVID. Each one of these little crystals it's paper craft. It's made of laminated cellophane, and they're squishy. They're like tab and slot folded, and I designed these in Fusion 360 and cut them out of my vinyl cutter, and then folded each one by hand. And as you can see, I did kind of a lot of them, and then put NeoPixels behind. And now I've got this running WLED, so they can sync with each other, and it's pretty cool. So the crystals are kind of the centerpiece. I've also got my little spiral lamp here with a little jellyfish on top of it. I'm doing an installation of LED jellyfish up in the mall as well. And then at the bottom, this whole thing, I'm calling it my Crystal Dream Garden. So the Dream Garden down here on the ground is I've got some just foam fiber fill and some pretty little LED branches from Amazon. And this very bottom part, this is kind of my newest tutorial. These are crystal garden path lights. They're just little crystal tracks. It's a NeoPixel with these little crystals glued on top of its garden edging. So I used caulk, like silicone caulk, clear silicone caulk, to put it on there. And like, look how flexible it is. Like, I can put it down anywhere. And then I made a whole series of 4-foot tracks, and they connect with little connectors. So they're modular. I can put as many in as I want in a row. And then WLED, which is running this whole installation, it can sync different sections together. So I'm able to put these on either side of my garden path or different areas of my yard. They're pretty waterproof, so outdoor is pretty possible with these things. And then like running animations, and I'm putting them up all over the place. I'm kind of in love with these things. They're really
totally.
Just launched a tutorial on how to build these guys this past week, and I am putting this whole thing up at the mall. It's kind of a mock-up here in my living room right now, but I'm putting it all up at the mall on Friday, and you'll be able to see it for a couple months if you're local to Sacramento. Come on down to Arden Fair and check it out.
Nice.
Yeah.
Yeah, I really like those papercraft crystals. You have a tutorial too on those, and I actually printed them out or cut them out on my Cricut and me and my nephew built a couple. They can be pretty therapeutic when you.
It was during COVID. Like every time I would finish one, I'd get like a little dopamine hit, which is so. I had a lot of free time, like we all did, and made a lot of crystals.
Yep.
So.
Very cool. Yeah. Please post the link in the Discord. These are so cool.
Thanks for sharing.
Thank you.
Have a good night. Bye. Bye. All right, to play us out, we're hanging out with Bob. There he is.
Sorry. Hey guys, how you doing?
All right.
Have a quick show and tell here tonight, and this is something I teased a bit on the show last week. I'll cover more tomorrow. So what's going on here? There was a project that Sam Blenny posted in the Learn Guide Playground about creating a gamepad tester. So plug in X input game controller and see the button presses. I mentioned this to Lamore and she said, hey, what I really could use is a similar thing, but for keyboard reports that show the 8 bits of what key is being pressed in hex. This is useful if you're doing HID development, if you have a weird keyboard and you want to figure out what it's sending as a command or control key, a meta key, that kind of stuff. And so what I've got is one of our Feather ESP32 TFT boards, and then I've got a Max 3421E USB hub or breakout, host breakout. So this allows me to plug stuff in. Usually we go the other direction with microcontrollers. This lets me plug stuff in, such as this keyboard here. And every once in a while, it'll actually just work when you plug it in, but usually it wants you to do a reset. So I'm going to do a reset here of the board. HID reporter shows the vendor ID for this particular keyboard that's plugged in here and the product ID. And then when you press a key, we get the 8 bits of the first 6 keys. So usually keyboards allow you to do 6 keys at once, and then weird stuff can happen after that. And so you can see here, if I press the 1 or the 2 or the 3 or the 4, those are sequential numbers. If I press all of them, you'll see we're getting them to all show up. So we know those are all keys that are showing up. And so that's the project. It's code I just posted, and I'm going to work on a Learn Guide for that. Someone may find it useful. You can also plug some other HID things. I've noticed mice will usually show up and give you 3 for the 3 buttons. You'll get 0, 1, 0, 2, 0, 3. Maybe some other stuff. So you can probably extend this, but this is what I'm putting together just to do a little bit of keyboard testing. I've got a couple of things that it'll do, like it'll let you know when you've unmounted it, and then let's see if it magically remounts this time. Yeah, so it remounted this time. It might have accepted another keyboard, but I think that's just a known thing about this chip, is that you kind of need a reset often when you plug something in for it to actually enumerate and power up the keyboard properly and all that. So that's the project. And that's one of my daughter's super cool keyboards, which she
I was going to say, I love the keycaps on it.
Yeah, it's like a maybe a 60%. It's pretty small, but it's pretty cool. So like function keys, you have to press a function key to get. But here you can see that those will show up as a different thing. That's cool. 1E with function. That's 3A. So that's the kind of stuff that you may be interested in if you're doing HID keyboard projects.
Nice.
I was going to say super handy if you spill your coffee on it and you're like, oh no, it's broken.
What is it sending? It's sending weird stuff now. It's constantly sending something. Yeah, this will let you know.
Very cool. And your workshop tomorrow?
Yeah, I'll be doing a little bit of this, diving into a couple of new things, CircuitPython Parsec and more. So come on by tomorrow to check it out in the workshop.
Cool, will do. Cool. All right, John, have a good night.
Thanks, you too. Thanks for hosting.
Yep, bye. All right, that's going to do it for the show and tell.
Yay.
Pedro?
I think that's it. Yeah. Checking the room. We're all good. And right on time, too.
Yeah, right on time. Don't go anywhere. At 8 p.m. We got Mr. and Mrs. Lady Ada are coming on to do Ask an Engineer. So we'll see you next week.
Awesome.
Thanks, folks. Bye, everybody.